Hello and good afternoon my dear kids. Welcome back once again to this short tutorial video for class 7 students for maths. Okay, so since from the previous videos, we have finished quadratic, we have finished exponents. So in this one we'll be doing a new topic, that is linear equations in one variable. Okay. Now, before moving on to the topic, I want you to just note down a few important terms or few important things regarding the topic. Okay. So the first thing in here is linear. What does linear means? The term linear means your topic was linear equations one variable. So the term linear from the topic means one. Okay. That is the power. The power of the variable will always be one. That is, in this chapter you won't have to deal with any variables with power greater than 1. Okay, everywhere there will be just the power of the variable will be 1, no matter what the variable are. Okay, and one variable, linear equations in one variable, that means you will be dealing with just one variable in an equation. The variable may differ, okay, because we know that we can use most of the alphabets, and the mostly commonly used are X, Y, Z, A, B and C, isn't it? Or you can use any other alphabets as well in order to denote a variable, isn't it? Now, okay, so you'll be dealing with, in this topic, you'll be dealing with just one variable, and that too with just one power of the variable. Okay, so but remember, here also the concepts, the basics of algebraic expressions will follow. Okay, the basics of algebraic expressions will follow. Okay, and yes, now and in this equation, in this topic, there will be equal to sign in an equation. The equal to sign. See, now what does equal to means actually? So okay, now see what I have written here, 2 equals to 1. So can I write 2 equals to 1? Can I write 2 equals to 1? No, I cannot, isn't it? Because I know that 2 means 2 and 1 means 1. So how can I write 2 equals to 1? Isn't it? What does equal to means? Equal to means equal, isn't it? Same. So can I consider 2 and 1 as same? No, we cannot, isn't it? That means we cannot write 2 is equals to 1. Instead, see this, now this symbol from equal to, if you cut it in the middle, this symbol became the symbol for not equal to. Okay, so you cannot write 2 equals to 1. It will be wrong to write 2 equals to 1. I can write 2 is not equals to 1. Okay, instead what I can write is I can write 2 equals to or 1 equals to 1. Okay, now say this equal to also plays very important role. So that is what I am saying with all this. Okay, now the next thing. Okay, the next thing now what happens is, see how an equation is formed. Simple. Okay, first of all let's assume how equation is formed. So if I say you that I have got certain, see, as I know, as I've already told you, the variable, I have already given you the difference between variable and a constant terms and all, isn't it? We have done in algebraic part. Variable means the term or the whatever alphabet is used to express a variable. Variable means we don't know the exact value till then, isn't it? In this one, what we need to do is we need to figure out the value of the variable. That is what we will be doing in this one. Okay, we will be figuring out the values of the variables. So suppose I tell you like this. Okay, so once I was going from home to school, so what did I got was I already had few number of pens in my pocket. Okay, so I haven't told you how many number of pens I have got in my pocket. So once I was going from home to school, I had few number of pens in my pocket. So what happened was, on the way to the school, I found 2 pens on the road. Okay, I found 2 pens on my way. So I have one, and what I did was I picked up 2 pens. Now I told you that once I picked up those 2 pens, so and I put it inside my pocket. Now the total number of pens inside my pocket became 5. Okay, so and my question is, how many number of pens does I had already in my pocket? So the answer is 3. Simple as that. So you can easily guess it that it has 3, isn't it? So how this is brought in equation? See, Suppose let's assume the number of pens I had already in my pocket was X. So I don't know, at the first we didn't need the value, isn't it? So let's assume it as X. What happened was, on the way to the school I found 2 pens. So actually it's added, isn't it? So X plus 2, see, because I have picked up those 2 pens and put it inside my pocket. So X plus 2 equals to, now it became, the total number of pens in my pocket became 5. So equals to 5. So see, this is how an equation is plotted. X plus 2 equals to 5. Okay. Now see, what an equal to does in an equation is, see, the equal to divides an equation into 2 parts. See, try to understand the basics properly. The equal to divides an equation into 2 parts. That is, see, when you are facing the equation, okay, so this is my right hand, isn't it? Other hand is my left hand, isn't it? So this side is known as right hand side. See, RHS, that's what I've written. And the another side is known as left hand side. Okay, what did I say? The equal to divides an equation. What is the equal to divide equation 2 halves? That is, this equal to divide equation 2 parts. See, this side and this side. So now this side is right, so right hand side. Another side is left hand side. So how an equation is solved is, what you need to do is, you need to keep a variable, just a variable in one of the sides and constant terms on one of the sides. That is how the linear equation will be solved. Okay, what you need to do, you need to keep the variable on one of the sides and the constant on one of the sides. Okay, so how will you do that? We'll learn slowly and gradually. Okay, so all you need to do is just a couple of arrangements and all, a couple of shifting and all. Okay, so okay, now since, see, as I've already told you, an equal to divides an equation. Now what happens? Let's see, whenever a plus changes its sign, plus changes its position, that is from left hand side, when a plus from left hand side goes to the other side, say equal to divided equation 2 halves, as I've already said, when a plus, it switches its position from left side to right side, it will become minus. Similarly, from when a minus comes from other side, switches its side, it becomes plus. See, it's vice versa. When a minus goes to other side, plus comes to other side, it becomes minus. See, okay. And similarly, whenever a multiplication goes to other side, it becomes division, and when a division goes to other side, it becomes addition. Similarly, division goes to other side, multiplication goes to other side, division. Multiply to divide, remember, multiply to divide, divide to multiply, plus to minus, and minus to plus. When it switches its position, remember, from left hand side to right hand side, only then, okay, not within left hand side or not within right hand side, only when it changes, it crosses the border. Okay, so okay, so what was our question? Our question was x plus 2 equals 5. That is how we plotted our equation, isn't it? Now see, x plus 2, and what did I say? When an equation is solved, what did I say? When on one of the sides is just a variable and one of the sides is just constant, isn't it? So what I supposed to do here, I need to take this plus 2 to the other side, isn't it? So what will happen? It's plus 2 is changing its side from left hand side to right hand side. What did I say? When a plus goes to the other side, what happens? It goes minus, isn't it? So that is why, see, this plus 2 when moved to the other side, on the second line it became minus. See, 5 minus 2 and 5 minus 2, it's a like term with opposite signs. So opposite signs subtracted. 5 minus 2 is 3, and sign of greater number follows. Greater number is 5, is plus 3. So the answer is plus 3. Now we have solved here. We have solved here. So how we have solved? See, simple. Equals to left hand side we got just a variable. On the right hand side we just got a constant. See, this is how we have solved. Okay, and also remember the value of the coefficient of the variable. The coefficient of the variable has to be 1, not more than 1. Okay, because see, even if we don't write 1, we know that the coefficient is 1, isn't it? So it cannot be 2 or more than 1, any other number. Okay, so okay, just one more example. Okay, now see how an equation is plotted. As I've already said, see, now the second condition, second day, what happened was I had few rupee in my pocket. Okay, and I was going to market. Okay, so on the way I wanted to have something, so I spent 20 rupees. So now see, try to understand the equation properly. Okay, I had few amount of rupees in my pocket. I didn't told you how much. I had few amount of rupees in my pocket. What happened was I wanted to buy something. I bought it for 20 rupees. Now what is left for me is on my pocket. Now after buying the item, I've got 30 rupees left. So if I ask you how much money do I had previously, then you will easily tell me, say it's 50 rupees, isn't it? But how do we plot it in equation? This is how we plot it in equation. See, the term, the money we didn't know the pocket, we'll assume it at x. See, x minus 20 because I have spent the money, so it's been subtracted. So x minus 20 equals to, how much is left? 30. So this is how this equation is plotted. See, now what happened? See, now what happened? See, x minus 20 equals to 30, left hand side, right hand side. So we got a variable and a constant term on the left hand side. So what do we need to take the variable to the other side, isn't it? So I've taken minus 20 to the other side. Minus 20 is changing its side from left hand side to right hand side. What happens? Minus becomes plus. So in the second line, see, 30 plus 20. And now finally x equals to 50. 30 plus 20 is 50. Now see, now what do I have? A variable on one of the sides, constant on one of the sides, and we are done here. What was our x? We assumed x as the pocket money that I had previously, isn't it? And how much did I had previously? 50 rupees. So x equals to 50. See? Okay? Okay. Let's go with the sums. It will be easier for you. Okay? Okay. The first sum I have taken is from exercise 12a. Same. Exercise 12a. What do I have on the first equation is x plus 2x equals to 9. Now x plus 2x. See, on the left hand side I got two variables, that two like terms. So x plus 2x. No, so that is why I said the concept of algebraic expressions will follow here. So x plus 2x is, what do I know? It is 3x, isn't it? So x plus 3x, 3x. See, 3x equals to 9. And you can tell me that it's just variable on one of the side and the constant on the other side. But what did I say previously? The coefficient has to be 1. But the coefficient in here is 3. And what is the relation of 3 into x? It's 3x, it's multiplication, isn't it? So what did I say previously? When multiplication goes to other side, what happens? Division. So see, this 3 went to the other side, it became divided. Division. So it is 9 divided by 3. And 9 divided by 3, we know that 3 1 times is 3, 3 times is 9. So x equals to 3. No need to mention 1 in the denominator. So x equals to 3. Now finally I got just a variable on one of the sides, constant on one of the sides. We are done here. Okay? Okay. For question number 2, what we have here is 3x minus x equals to 8. Now again, the variables on the left hand side, we got two terms, variable, two variables, same variables, two terms, isn't it? That can be subtracted because they are like terms. So 3x minus x is 2x. Okay, the coefficient will be subtracted, isn't it? 3x minus x, so 2x. Now again, see, the coefficient is 2, so it's, we are not done here. So the relation is multiplication, so goes to other side, division. So 8 by 2. So 2 1 times is 2, 2 4 times is 8. So our answer is x equals to 4. See, finally, just a variable, just a constant term, and we are done here. Okay? Okay. Question number 3 we have here is x plus 3 plus 6 equals to 14. Now see, these two terms, they are like terms, isn't it? And also they are with same signs. So same signs can be added, we know that, and the sign remains same. So x plus 3x will give us 4x. Okay, now this plus 6 is a constant term. Okay, so we need to take constant term to the other side, isn't it? That's what we are doing. So plus went to other side. Remember, it has changed its position. In this line 6 was on left hand side, and here it came to right hand side. See, the equal to the boundary, isn't it? So it crossed the boundary, so it became minus. So 14 minus 6, again like terms, so it is 8 out here. So now again, the coefficient of x, what do I say? It's 4. So not happening. We haven't solved the equation yet, isn't it? So, and the relation is multiplication. So multiplication goes to the other side, division. So now for 1 times 4, 4 2 times is 8. So, and we got our answer as x equals to 2. Okay. Okay. Now this one. What do I have here in question number 6 is 3 within bracket. I got x plus 1 equals to 15. What does bracket means? Multiplication, isn't it? So I can simply take the constant term to the other side, and I know that multiplication goes to the other side, becomes division. So 3 went to other side, divided 15. We know 3 1 times 3, 5 times is 15. So that is what I have written. X plus 1 equals to 5. Now have we done here? No. Why? Because on the left hand side still we got a constant term with a variable. That too with addition relation. So now what we need to do? We need to take this 1 plus 1 to other side. Side changed. Plus is changing its side. Plus 1 is changing its side. So it became minus 1. So x equals to 5 minus 1. That is x equals to 4. A variable, a constant. And we are done here. That too variable with coefficient 1. Okay. Okay. Let's do a few more sums. It will be easier for you. Okay. Okay. Now for question number 7, what do we have is, question number 7 is 9x plus 5 equals to 4x plus 30. Now see, we got a variable with a coefficient plus a constant term. Again, a variable with a coefficient and constant term. So what I am doing here, I am simply I am switching the variables, all the variables to the left side, the constant terms to the right side. So this, what is actually the sign of this 4x out here? It's plus, isn't it, on the right hand side? So it's changing its side. Since the variable, the sign is not given, that means it's a positive integer, isn't it? So plus went to the other side became minus. So 9x minus 4, see? And this plus 5 went to the other side became minus, see? So what we have now? We have 9 minus 4x, like terms, so it will give us 5x. 30 minus 5 is 25. Again, the addition multiplication, coefficient we have 5. We are not done here. 5 goes to other side. Division, 5 1 times is 5, 5 5 times 25. So the value of x is 5, x equals to 5. We are done here. Okay. Okay. Second one, what we have, again the same thing, that is 5x plus 2 equals to 3x plus 12. Again, term with a variable, let's take it to left hand side. The constant term, let's take it to right hand side. So we have here 5x minus 3x equals to 12 was already there with a plus sign, so 12. 2 went to the other side minus 5x minus 3x. See what I am doing here. What did I say at the previous? Variables on one of the sides and constant terms on the one of the sides, isn't it? That is what I am doing here. See, 5x minus 3x, I know it's 2x, equals to 12 minus 2 is 10. Again, the variable coefficient is 2, so I need to get rid of the 2 as well. How will you do that? Relation is multiplication, goes to the other side, division. So 2 1 times 2, 2 5 times 10. So we got a value of x is 5, x equals to 5. Okay. So for 13, what do I have is, see, for 13, I got 2 within bracket x plus 2 plus 3 equals to 9. See, now in this case, I cannot take this 2 directly to the other side and divide it. Why I cannot do that? Because it's not monomial. Remember, it's binomial. We can only do that when it's monomial. Okay, this is just one term. Okay, 2 into 1 term. So, first of all, what we are supposed to do? See, what I have done here, I have taken the constant term to the other side. So when I take plus 3 to the other side, what happens? It becomes minus 3, isn't it? So the term on the left remains same. See, no change of anything, sign or anything. So 2 within bracket x plus 2 equals to 9 minus 3. So 9 minus 3 is 6. Now what we can do is take 2 to the other side. Monomial it became now. See, 2 into. So this 2 went to the other side, we can division. So 6 divided 2 to 1 times 2, 3 times is 6. So now we have x plus 2 equals to 3. We are not done here. Why? Because still we have got a constant term on the left hand side. Now taken 2 to the other side, what happens? Plus 2 became to the other side, became minus 2. So 3 minus 2 is 1. So x equals to 1. We are done here. Variable, constant, separately, and coefficient also 1. Okay? Okay, number 14. Again, the same thing. 7 plus 3 within bracket x plus 5 equals to 31. Now, what are we supposed to do? Take 7 to the other side, isn't it? So once you take 7 to the other side, what happens? See, 3 within bracket x plus 5. We got monomial now. 31 minus 7. 31 minus 7, we know it's 24. Plus 7 went to the other side, minus 7. So 24. Now what happened? The 3 can come down. So because it's multiplication relation, so multiplication goes to division. So we know that 3 8 times is 24. 3 8 times, see, 3 8 times 24. Now x plus 5 equals to 8. 5 goes to the other side again. X minus 5, 8 minus 5, that is 3. So we are done here. Okay, I hope you kids are getting the point now, isn't it? Okay, just few more sums. Okay, for 15, 3x plus 2 within bracket I got x plus 50, x plus 5 equals to 40. Now in this one I cannot take 3x to other side, isn't it? Can't I? Can I? Because it's already a variable, isn't it? So why to take variable to other side? Instead what you should do is simply open up the brackets in this one. See, multiplication monomial and a binomial. See, what did I say? The basic of algebraic expression will follow, isn't it? So this 2 will multiply both the terms. 2 into x is 2x, plus into plus is plus, 2 5 times is 10. Now what you can do, see, we got two variables together, so the constant term has to be taken to the other side. So 3 plus 2 is 5x. I have taken 10 to the other side, so it changed the sign to minus. 40 minus 10 is 30, 5x, quotient is 5, x equals to 30 by 5, so 5 1 times 5, 5 6 times 30, x equals to 6. We got our answer. Variable constant separately. Okay. Now here we have another question as x equals to 17 minus 3 within bracket 2x plus 1. Again, we cannot just simply take the term to the other side, isn't it? So what I have done here is, or you can just simply open up the bracket first. Okay, it will be easier for you. So opening up the bracket with a negative sign. Minus into plus is minus, 3 2 times 6x, minus into plus is minus, 3 1 times is 3. See, after opening up the bracket, what do I see? I take one variable term, isn't it? And you take it to the other side. So minus 6x, so I'm taking it to the other side. What happens? It becomes plus 6x. So see, x plus 6x, and the other side we have here is, this is equal to sign, okay, equals to 17 minus 3, we have another side. So 6x plus 7, x plus x, it's 7x, equals to 17 minus 3, it's 14. Coefficient is 7, it's not happening. You need to take coefficient also to the other side. So the other side I have taken 7 1 times 7, 7 2 times 14. We got x equals to 2 as answer. Okay, and we are done here. Okay. So the final question for today, let's listen. Okay, what do I have here is 5 within bracket 2x plus 6 equals to 38 minus 2 within bracket 5x plus 6. So again what we need to do, first of all open up the brackets. So 5 2 times 10x plus 30, 5 6 times 38. I hope you know how to multiply it, isn't it? Because this is what we have already done in algebraic expression as well. Minus plus minus, 2 5 times 10x, minus plus 2 6 times 12. Now arrange the variables. So I need to take 10x to the other side, and I need to bring 30 to the other side. So this 10 went to the other side, became plus 10x. 10x was already there. 30 came to the other side. 38 was already there. 38. See, plus 12 was already there. So plus 12. 30 come to the other side, become minus 30. 10 plus 10 is 20x. 38 plus 12, it's how much? 50, isn't it? So 50 minus 30. 50 minus 30 is how much? 20, isn't it? Now the coefficient of x is 20. So I need to take the coefficient also to the other side. So x equals 20 by 20. 20 by 20, we know it's 1. 21 times is 1. 1 by 1, you can write it as 1, isn't it? So that is how we get the value for the variable. Okay. So I hope you kids have understood today's lesson. Okay. And what I want you to do is, I want you to practice the remaining sums as well. Okay. If you have any problems, then please do let me know. Okay. And stay tuned in for more videos. And till then, stay safe. Bye bye.